Welcome to the Electric Wire Podcast. We bring you news and views on the most pressing issues facing Wisconsin's electric industry, from policymakers, executives, and customer and environmental advocates. Bringing you these discussions, we are the Customers First Coalition. Here's your host, Executive Director Kristin Gilkes.
Welcome, listeners, to a very special episode of the Electric Wire Podcast. I'm your host, Kristin Gilkes. And as many of you know, at the end of 2021, I manifested or predicted an episode on wind turbine blade recycling for 2022. And now here we are in the first episode of the year, and I think you're all going to be big fans of this episode. I asked Tyler Huebner of the Public Service Commission of Wisconsin to join as my co-host, and we're joined by Nicholas Killen of Vestas to shoot the breeze on some of the major topics surrounding this issue. So quickly, I'll give you a little bit more on each of them. Commissioner Tyler Huebner was appointed by Governor Tony Evers to be a commissioner at the Public Service Commission of Wisconsin in March of 2020, and he was reappointed by Governor Evers to a 6-year term, which began on March 2nd, 2021. Prior to joining the commission, Tyler had been executive director of Renew Wisconsin, a statewide renewable energy nonprofit, since June of 2013. Nicholas Killen has worked with Vestas for 14 years in several roles focused on the manufacturing of wind turbine blades. Within his current role as head of Manufacturing Lifecycle Services, Nick has been developing solutions for the repair, refurbishment, and recycling of composite materials. One of his current projects involves expanding the range of commercially viable options for recycling end-of-life wind turbine blades in North America. I'm so excited to be joined today by Commissioner Tyler Huebner of the Public Service Commission of Wisconsin. He is going to be co-hosting with me today, and we could not have found a better co-host with greater expertise in this area. So thank you so much, Tyler, for joining.
Well, thank you so much for having me, Kristin. This is an exciting interview that we had today with Nicholas, and got a lot of information. And absolutely, it is an important issue as wind turbines. We continue to have more wind farms across the country, and I know that industry continues to grow. And so the topic is certainly right on target today.
Some of the topics we covered with Nicholas are more about Vestas, more about wind turbines themselves, the lifespan, how the recycling actually works, what do some of the recycled materials become, and the future and timeline for recycling of blades. And we got all the power perspectives from both Nicholas and Commissioner Huebner, so you want to stay tuned for that at the end. Thank you again, Commissioner Huebner, for joining, and we will turn you over now to our interview with Nicholas Killen. Welcome, Nicholas, to the Electric Wire.
That's very good to be here. Thanks for having me.
All right, so let's start by having you tell us a little bit about yourself and how you got to your current role at Vestas.
Sure. So I never anticipated working in the renewable energy industry. It was kind of a side effect of what I was doing at the time in 2007 when the economic recession sort of hit. And right about then, as I was transitioning out of a business I was running at the time, Vestas decided to build a blade factory in Colorado, in Windsor, Colorado. So I applied to that. I was hired on as employee 21 and had the opportunity to start doing the technology transfer from Europe to the US of how to build these blades, and then had a opportunity to continue to grow with that role over the next several years, going from that factory to a second factory we started up in Brighton, Colorado, and then eventually working with our tooling division in Europe before moving on to my current role.
Well, thank you for that. And we are just so delighted to have you here to talk more about your current role and how it relates to wind turbine blade recycling. So can you tell us more about the current role that you're in and what you're doing there?
Sure, absolutely. So my current role is the head of Lifecycle Services, and what we're targeting here is anything to do with the repair, refurbishment, or recycling of wind turbine components. Our focus primarily over the last year and a half has been with the wind turbine blades. And the reason for that is the core of our workforce, where we started this business, came from our blades factory in Brighton. And also some from our Windsor factory as well. So a lot of highly specialized technicians with repair capabilities, can work up tower, down tower, and just a wide range that we can apply to this, to the problems that we see in this space.
In your role, do you cover the whole globe or certain regions for the company? I know Vestas has a worldwide presence. Could you tell us a little bit more about that?
Sure, we are focused in North America primarily. I have a couple teams that work down in South America and Brazil, but the focus is almost exclusively North America, with a heavy emphasis in, of course, the US, between Texas and Minnesota. That's where most of the work is.
Great. Well, Nicholas, thanks so much for being on. Before we talk about recycling the wind turbine blades, I thought it would be really helpful for everyone to understand what materials are used to make the blades.
Absolutely, and great questions. That actually leads into why it can be quite challenging to recycle these components later on in their lives. So the most obvious components is fiberglass and epoxy. Fiberglass in a lot of blade types is going to make up the vast majority of what actually gets laid into the mold that forms the structural sort of shape and strength of the blade itself. And of course, like any other composite product, we use an epoxy, typically a 2 or 3 part epoxy, to fill in that matrix and give it its final shape and plasticity. Some other materials that you'll typically find are carbon fiber that came into more use in the, let's say, mid to late 2000s and is now very commonly used in wind blades. And of course, what we refer to as core materials, which is any light but stiff filler material that we can use to create the different shapes we need inside of the airfoil itself. Some typical example of this are balsa, PVC foams, or PET foams.
What's the lifespan for the typical wind turbine blade?
Sure, the typical blade is going to be designed with the intent of it operating for the entire life of the wind turbine. And in most cases, that's going to be targeting at least 20 years.
It's only recently that we've started hearing more about the recycling of the wind turbine blades. How did that process get started, and how does the recycling work?
So how to handle wind turbine components at end of life has been a problem for the industry for a very long time, at least a decade plus. But there was kind of a watershed moment a few years ago where there was an article run, and this picture was taken in, I think it was Wyoming, from a drone showing this, huge field of wind turbine blades that have been sectioned and placed into a hole, and this massive bulldozer pushing dirt over them, right? And that kind of moment really galvanized the industry and its critics to say, hey, something's wrong here. Are we really living up to our values? And is renewable really renewable if we see things like this? And of course, there's a couple of misconceptions behind that picture. One of the more common which I run into is the idea that the waste from the blade is somehow hazardous or toxic. These are inert materials. They can be put in the ground. The problem is once they're in the ground, nothing happens to it. It just sits there, right? So it's really a terrible use of this waste at the end of its life. Where that came into my journey with Vestas and this particular team is Vestas came out with some very aggressive sustainability goals 2 years ago. One of which was to up the total recyclability percentage of the turbine at end of life, and another one was to go waste-free in our manufacturing processes. I became involved in that for the North America region pretty early on, and so we started exploring what were our options to support these initiatives. One of the ones that came to mind pretty quickly, or at least was very exciting for us, was the idea of going after the blade recycling piece. So we launched a proof of concept project about 1.5 years ago. And at that point, it was really more of what are the options, what can be done, when can this be feasible? And we were pretty surprised to find out within a matter of months that not only could it be done now, but it was on the verge of being commercially viable at scale. And so that proof of concept project quickly shifted from let's see if this can be done at all right now to how do we commercialize this as quickly as possible and get the highest number of blades recycled to the entire industry's benefit as quickly as we can. And that's kind of where that project has led us to today. We've executed several commercial scale projects over the last year. We have a few more scheduled for this year, and of course, some pretty aggressive targets for expanding that. But really, that's only addressing the populations of blades that are at end of life now. So there's two kind of different classes of problems that we're facing. One is what do we do with all the blades that have been constructed up until now? And the second half of that problem is what do we do, or what can we do differently with blades that we're manufacturing tomorrow and for into the future to make them inherently easier to recycle and more reusable long-term? Most of what I've been focusing on up to this point is the first half of that problem. What do we do here and now with this rather large population of blades? But I would be remiss if I didn't mention that Vestas also has two very large projects based out of Europe that are addressing the other half of that problem. What are the materials we can use that make it easier to recycle long-term? And then what industry partnerships can be used globally for that long-term future?
How does the recycling process actually work? Are you the ones doing that, or do you contract out for that? And what are they doing? Grinding it, or what's happening?
So I'll give you the simplest answer that I can to this, which unfortunately isn't going to be that simple, but I'll do my best because there's a lot of, let's say, options in that process. If we subdivide it into a couple basic steps, the first step is whatever happens at the wind farm. The second step is the transportation of that material. The third is the preparation of that material for recycling. And the last step is the actual recycling itself. Now, a lot of times when people ask me that question, they're really curious about that fourth step, but I'll touch on all four of them briefly, and then we'll spend a little more time on the fourth one. So what happens at the wind farm itself is a consideration that doesn't get enough attention in a lot of cases, or at least historically has not. A lot of landowners are pretty, let's say, resistant to the idea of someone showing up with a shredder or other heavy industrial equipment and starting to cram fiberglass through it, potentially generating dust or debris that has to be picked up or sorted out afterwards. So the methods that are used on site are pretty critical to maintaining the stakeholder relationship there. There's also a pretty strong desire with industry to be off the wind farm as soon as possible. So you could certainly create a plan, if you've got 100+ turbines, you could create a plan that was anywhere from 3 to 6 months long. But if you, depending on how you were planning to get it off site, you could actually potentially take longer to get that material off site. And really what everyone's looking for is once that turbine's down, the material's gone the next day, right? And we're very rapidly moving towards that capability. The second part I mentioned, which is transportation, is so critical because as of right now, it's the largest cost driver in that entire value chain. And depending how far you are from your final recycling and what kind of load densities you can hit, you can really take a business case from being viable to being completely upside down pretty quickly. So it's a space that doesn't have enough innovation yet, but is certainly on everyone's minds that's operating in this market. The third piece, which starts to touch on what I think you were asking about, Kristin, which is how do we prepare this material for recycling? The most common method by far is to put it through some sort of shredder or chipper. A large industrial machine that might be used at a junkyard or other industrial processor where you can take this material, put it in, and it's reduced in size to something that's manageable for the final recycling process. And then, of course, leads us to the fourth step, which is the final recycling. Of the methods that are technically viable right now, of course, the highest possible reuse is to actually refurbish and reuse the blade, which is something that is getting more and more attention, particularly for some of our turbines that have really good performance, historical performance over its lifespan, that are easy to refurbish and can be relocated to a secondary market. But obviously, that's the best we can do, right? Because then you're not recycling at all. It actually gets a life extension. It keeps going. From there, as we go down, the second would be to actually harvest the materials out of that blade and then reintroduce it into the supply chain, preferably in a manner that allows it to be used for a new wind turbine blade. Step down from that is to make some sort of other product that may or may not be also recyclable. The most common example of this at the moment is the production of concrete or cement. And then a step down from that would be to use that material from the blade in another composite product. So think taking these chips of fiberglass and pressing it into a brick or a sheet of plywood-like material, something of that nature that maintains some of the desirable characteristics of a composite, but can be formed from the leftover material. So those are kind of the range of options. Of those, by far the most commercially viable at the moment is the cement co-processing, where the material goes into the cement kiln, the organic fraction of that material is burned off to fire in the kiln, and then the residual material from that goes directly into the cement making process where it offsets the consumption of either sand or other filler materials that go in. In some cases, the fiberglass content can be desirable because fiberglass and concrete can up some of the characteristics of that and make it more desirable for different engineering specifications of concrete applications. And there is kind of a situation there where the use of that material in the cement kiln typically does lower the emissions of the cement kiln as well. And of course, makes it so they don't have to use a traditional fuel source while they're doing that firing. The volumes that we see that are possible with cement co-processing at the moment are really just starting to support the amount of waste that's coming from end-of-life turbines at the moment, and it's likely what's going to carry this segment of the market over the next several years. The intent is to move immediately after that to something that does harvest the materials themselves and allow it to go back into the supply chain, preferably for the production of new wind turbine blades. And what we're seeing is that capability is just coming into viability right now, and could potentially overtake everything else for the next 2 to 3 years. And of course, that's really where our focus is at the moment and where we want to see things go as soon as possible.
Well, Nicholas, thank you for that excellent description of what the process is looking like for Vestas. I had a quick kind of clarifying question on the transportation. I know that moving the blades are so long these days, moving them, transporting them is a challenge. So it sounded like, though, that because the farmers and the landowners want those blades off site sooner, that you're basically transporting the full length of the blade, off the farm and to that next step. Is that true? Or are you maybe at least cutting it in half in order to make the transportation easier or something like that?
Sure. So whenever we're talking about transportation, we want to avoid any additional costs that we can. And one of the easiest of those to avoid is the permitting and special trucks and escorts and that sort of things that come along with transporting a full length blade. So it's and the great thing about this is we no longer need these blades to work, right? So we can very easily go in and cut them up or reduce them in size in some way and not worry about the effect on the structure of the blade. It's more like, how do we just get this mass of material wherever we need it as efficiently as possible? So yes, absolutely. We put a lot of thought into where do we cut each blade based on what blade type it is by manufacturer, materials inside of it, type of construction, things of that nature. Where do we cut it? How can we nest it or otherwise get it onto a trailer or container or other mode of transportation as efficiently as possible to get as high as we can with the load weight, right? So when I mentioned density earlier, that's what I was talking about. We want to hit within that space that we can transport in a non-permitted environment. How do we get as much weight as possible within that without going over? And then, of course, that affects the business case quite dramatically by changing the number of shipments that we have to make.
Yeah, that makes a lot of sense. That was the first thing that stuck out to me. And so, as you just said, the business case and the cost competitiveness. Can you tell us about what are the costs and benefits of going down this road of recycling the blades?
Sure. I would say one of the misconceptions that I can run into fairly often, at least at the moment, is the idea that maybe this blade waste is inherently valuable. And I'm sorry to say that for the moment, it is not. There's no one that's going to pay you to take these blades away and turn them into some other product. With an asterisk, they're saying yet. That could possibly change, probably will change in the next 5 to 10 years. But certainly where we are right now, that's not the case. So it really comes down to a balance between what are the sustainability goals and values of the organizations that are involved. What is the comparable cost for lower levels of disposal, whether that's direct landfilling or something similar? And are there any regulatory or other incentives that could swing that cost picture either direction? So a couple of examples to think about. One is if the landfill in the area will even accept this type of waste. Right, so you may have a great rate by ton, but they won't take it either because they don't want that drone flying overhead taking the next version of that picture, or because they could be running out of space. And blade waste has a large volume to it, so it could be consuming too much space. It's a problem we see, of course, more in built-up areas that have been habitated for a long time versus, let's say, the Midwest. But it is still a significant question in a lot of business cases that we analyze right now. The other aspect of that is if there is any sort of regulatory penalty or mandate that prevents landfilling, and that of course would also swing in the other direction. And the third major piece of that, which is why I mentioned transportation earlier, is how far away are we from the nearest recycler? There's a lot of cases when we are within a certain radius of a recycler where we can actually compete directly with landfilling, even now, without those other factors involved. So as we see more locations pop up around the country that can receive this waste and actually handle it in some sort of level of recycling, it's going to become more and more viable to the point where landfilling is going to stop making sense. So that one of our missions at the moment to support that is to develop as many locations as possible to be able to do this. One of the easy things we look for is any cement kiln that does handle alternative fuel sources at the moment, because typically, and I have to emphasize typically, not always, it's not a huge stretch for them to start to accept this waste as well and actually put it into their process.
With the typical life cycle of a blade being about 20 years, I'm thinking back to about 2002. Are there any initial projects that are coming offline where you're seeing an increase in the need for recycling now, or is it sort of one-offs that you're working on now? What's the status now, and where do you see it in 5 to 10 years?
Sure. So there's two main types of projects that we focus on at the moment. One is that sort of one-off range, which is 1 to 3 blades, somewhere in that range. And those blades can be anything from a turbine that's been operating for 20 plus years to a blade that was being shipped to a new turbine installation that was damaged and could not be repaired. So we see that full range within that scope. The other scope is, of course, the major projects, the whale projects, if you will, whether it's a repower or a significant site decommissioning. And both those different types of projects have significantly different challenges. The one-offs, of course, are all about agility and being flexible with where you route that material and how to execute as quickly as possible, right? And when we get into larger projects, it's all about efficiency, while typically bearing in mind what's important to the stakeholders. So lots of different challenges to that, but that's primarily where we focus at the moment.
Nicholas, it's been great to hear what Vestas is up to. Can you talk to us a little bit about your competitors or industry peers that are also in the wind turbine manufacturing industry and what they're doing? Are you working with colleagues that are at other companies to make this more industry-wide? What's the status of that?
The short answer is yes. We're working with all our competitors and all of our colleagues and collaborators across the industry to solve this challenge. This is a challenge for everybody across the board. And if we don't come up with a solution proactively that supports everyone's goals, eventually it's going to be dictated to us in some way, shape, or form, right? So there's some very significant initiatives. One that I can mention by name is DCOM. That's a project that we run with a lot of our colleagues in the manufacturing industry out of Europe. There's plenty of material on Vestas's website where you can research some of the details around that. But that's specifically what that's talking to, is how do we collaborate on the solutions for not just the blades themselves, but the recycling methods. Where does the material get routed to? Essentially the entire value chain around that waste coming out of the end-of-life turbines. Here within the US, we do have a number of folks that we collaborate with. The main emphasis is on two things: getting more capacity online. As I mentioned earlier, there just isn't enough. If we decided tomorrow to recycle every blade coming at end of life this year, we simply wouldn't be able to do it, even if the money was there and the willpower was there. So we're very much focused on getting capacity up, which in turn also helps lower the cost per ton recycled, and allows us to just continue to spin that wheel faster and faster and get more throughput. So yes, lots of industry collaboration across the board on how to get this done.
Okay, that's great to hear. So Nicholas, as we stand here today and look forward, what needs to change to be able to build blades that are more recyclable?
Yes, this is a topic of much interest across the industry and across the vast majority of our public-private partnerships at the moment as well. So the simplistic answer to that question is around two things, call it three. One, the materials that we use themselves. What materials can we bring in that are inherently easier to break down or to separate out of the composite or otherwise reclaim? The second piece is what to do about the epoxy question. So for example, right now, the only way for us to get the epoxy separated from fiberglass that are, let's say, viable, are to either burn it off, which is going back to the cement co-processing method I mentioned earlier, or to use some variation of a pyrolysis technique where we essentially also burn it off, but do it in a manner that's less damaging to the fiberglass and allows the fiberglass content to be recaptured. We do get some organic fractions off of that, so there's some hydrocarbons and things that can be captured and reused during that process, but it doesn't come back as epoxy, right? So the second part of that is to start to use different epoxies that can be separated again afterwards. So you get your hardener and your base and actually pull them back apart and then potentially reintroduce them into building another blade, which I'm not a chemist, so I cannot explain the details of that to you, but at a high level, that's the idea. And the third answer to that is in the actual design of the structures of the blade itself. How do we either piece together, glue together, or change where the materials are at inside the blade so that we can still accomplish the goal of the turbine, but end of life, separate those large structures apart from each other more easily without having to shove everything through one grinder or do something that's very labor intensive.
Well, thank you so much for that, Nicholas. Is there anything else you wanted to add before I get to our last question here?
Nothing comes to mind immediately. It's been a pleasure to speak with you both today and talk to something that I have a passion around. So thanks for the opportunity.
Well, we were just so excited to have you join and really appreciate it. So my last question for all of our guests is, if you had all the power in the industry, what would you do with it?
And I have to say, what a fantastic question. I've been pondering how to respond to this one for since you told me it. I don't know that I'm smart enough to give the answer to what to do with all the power in the industry, but definitely something that I would make sure had enough attention is the renewable energy industry in particular always living up to the values that we say we are? Whether that's around long-term sustainability, around how do we factor in some of the softer aspects of our business cases when we're making business decisions, and also how are we contributing to global problems like energy inequality, for example, and how can we advance other social causes along with providing clean and less expensive energy. So that's my half answer to your question, but definitely also something I'm passionate about.
Really something to think about. And Commissioner Huebner, thank you so much for joining us. I feel so lucky and honored to have you as a co-host. And I wanted to pick your brain and see if there's anything you would do if you had all the power as well.
Well, again, as Nicholas said, I don't know that I'm smart enough to know what to do with all the power, but I think a headline today or yesterday on batteries in the same vein. And so I think I'll piggyback off of what Nicholas said. And I think figuring out the life cycle of the generation technologies that appear to be growing at a fast pace and making sure that as they grow, there's a sort of a planned what to do with those materials at the end, and whether we can put that back into new wind turbines, new solar panels, or just find a good second use, a second life for them. I don't know all the answers. I know there's a lot of people working on it. I think the sooner we can figure that out, the more ease of mind and peace of mind it will give policymakers and others as these new technologies continue to fall in costs and be economically competitive as well. So good luck to everybody working out there. I think today we had an excellent call for materials science education, and we need a lot of engineers out there that are material scientists coming through the pipeline. So looking forward to a new crop of great talent coming into this industry as well.
Good. Well, thank you both so much. Nicholas, if people wanted to connect with you after this or follow what you're doing, learn more, where could they do that?
Absolute easiest thing to do is look me up on LinkedIn under Nicholas Killen.
Perfect. Thanks. And Commissioner Huebner, I'm sure you want to plug the Public Service Commission of Wisconsin's Twitter page, right?
We are getting active on Twitter. We have an excellent communications lead, Jarrell Ballard. So shout out to him. Absolutely. Find us on Twitter.
Awesome. It's at PSC Wisconsin. All right. Well, thank you so much. Thank you both. I loved this discussion. We've been waiting for it for a while. So appreciate you both making it happen.
Thank you so much. It was a pleasure to be here.
Yeah, thank you, Nicholas. This is great information and looking forward to our listeners learning a lot more about this topic. Thank you.
Thank you to all of our listeners for tuning in. Please support our work. You can subscribe to the Electric Wire podcast if you haven't already, and you can follow us on Twitter at The Electric Wire. Thanks also to the members of the Customers First Coalition for supporting this podcast. Our members are Dairyland Power Cooperative, Madison Gas and Electric, the Municipal Electric Utilities of Wisconsin, WPPI Energy, Renew Wisconsin, the Citizens Utility Board, the International Brotherhood of Electrical Workers Local 2150, and the Wisconsin Electric Cooperatives Association. Thanks again for listening. We'll have a new episode next month.